If you had to guess what the main piece of evidence supporting evolution was, what would you guess? If you guessed fossils, you'd be correct. In fact, fossil remains are some of the most concrete evidence that we have that evolution has and is occurring. Most people know that fossils are important in helping us understand the past, but you may be wondering some things. First, what role does DNA play in evolutionary studies, and why isn't it the main source of information? DNA is an important source for information on evolution. It's used often to discover new information on organisms whose fossils still have DNA, but therein lies the problem. Not all fossils still have viable DNA. DNA has a half-life of 521 years. That means that any readable DNA degrades in about 1.5 million years. That's helpful for any DNA found on fossils that are younger than 1.5 million years, but what about fossils that are 5, 20, or even 50 million years old? Second, why don't scientists just examine evolution as it happens in front of us? It turns out that speciation usually takes hundreds to thousands of generations, and depending on the organism, that could be millions of years. In fact, the average time for speciation is 2 million years. In some cases, it takes 10 to millions of years to take place. Needless to say, we can't watch evolutionary changes in real time. That's why fossils are so important. They give us incredible information that we wouldn't otherwise know. They give information on how our bodies, both size and shape, have evolved, which gives additional information on how little things, like the way we walk, has changed. Fossils can even give us information on diet, brain structure, and many other important aspects regarding changes in human life. Suffice it to say, fossils are extremely important, but fossils are also extremely rare. To help us better understand why fossils are so rare, Dr. Lee Berger, paleoanthropologist, gives us a few examples of what can happen to an organism after it dies.
If something dies out here on this environment, even today, and this is a fossilizing environment, today it's likely never to make it more than a couple days. The reason being is all the scavengers and predators. Maybe a leopard made the kill initially. Then vultures come in and they start eating the remains and ripping it apart and distribute. Then at night, hyenas come in and they start tearing it, carrying off bones and pieces. Then all the small animals and insects come in, and within a matter of hours to days, there can be absolutely not even a bone left of even the largest animal that's killed on this environment. So it's a hostile environment. Even if the bone survives on this environment, it's being weathered by the sun and rain and deteriorating, and there's nothing to actually impregnate it with the minerals and stuff that would need to make it a rock, which would last longer. So things on the surface, they deteriorate, they decay, they go through natural processes.
If fossil formation is so rare, how and where do we find them?
But once they get into the magic of one of these caves, once they're protected from that environment, from the animals, from the predominance of insects, they sit quietly on the floors of these caves. And a lot of then chance events can happen to them. Maybe there's an earthquake and debris falls on them and they're covered. Maybe there's a big rainstorm and mud and soil is washed from outside and they get washed into a pile into that. Maybe they're just slowly covered by time, or maybe they're covered by, maybe they just happen to lie under one of those drips you saw coming from the ceiling, one by one. And once they're underground and buried within one of these environments, they're protected, and then they're surrounded by some of the most lime-rich or calcium carbonate-rich soil you could ever get. And then over time, they're impregnated by the minerals that surround them. And as gentle water saturates these wet and humid environments, those minerals can be transported into the calcium phosphate that is the bone, and you get replacement that goes on. Replacement calcium phosphate with calcium carbonate, maybe manganese impregnates there, and eventually you turn a bone into what we would term a fossil. And obviously in that there's huge degrees from something that's just started to something that's turned into effectively nothing like the original, but a perfect cast of it.
Considering the millions of years that fossils need to endure and the countless reasons that they shouldn't, it's amazing that they even exist in the first place, and thankfully they do, because they teach us so much about where we come from.